Hey everybody! Welcome to part 3 of Introduction to Geometry Nodes. We've had a lot of fun seeing some of the possibilities in the first 2 videos, but let's look at a more complete practical example. We're going to make a very simple procedural landscape. Let's turn off all of our existing meshes, both for visibility and for rendering. And now we'll add 2 collections. We'll name one trees and the other boulders. Now in the trees collection, let's add a few cones and size them differently. We'll go back to our layout workspace to do this. Let's be sure to set the origin to the 3D cursor. Now we can duplicate and scale these. Our aim here is not obviously hyperrealism, but think of this as more of a prototype. Now let's add some boulders to our boulder collection. Let's just randomly grab some vertices and use proportional editing to give these some natural variation. We'll duplicate these the same way we did for our trees. We can move them up on the Z-axis and be sure our origin is set to the 3D cursor. If your 3D cursor is not at the world origin, you can use the Shift-S menu and choose Cursor to World Origin, or you can use Shift-C. Setting the origin will be important for placing our objects in the scene, as the origin will line up with our point object when we instantiate them. Let's go ahead and name our objects. We'll use Boulder 01, Boulder 02, and Boulder 03, and similar names for our trees. We can also make these objects invisible and remove them from render as well. Now we're ready to dig in. Let's add a plane and name it to Landscape. We'll create a new Geometry Nodes modifier and we'll rename that to Landscape Creation. Let's take our input and scale it with a transform geometry node. Let's scale the X and Y by 20 just to give us a large area to work with. Our Z dimension is 0, so whether we scale that or not, it will remain 0. We'll add a subdivide mesh node and bump the subdivisions up to 5. Now we don't want our landscape to be like an Indiana cornfield, so we'll add some variation in elevation. Let's add a set position node and plug a noise texture into the offset. We can see some ripples in our texture, but ideally we only really want to displace it on the Z-axis. So let's add a combine XYZ node and plug the noise directly into the Z value before bringing it into the offset. The reason we need this node is because we can't plug directly into just the Z-axis. The socket expects all three, X, Y, and Z values. And we can see by not setting the X and Y that they will remain with a 0 offset. So what should we do if we wanted this Z-axis offset to be more pronounced? There are actually a couple of ways. We'll look at the simpler one first. This is to just add a math node and set it to multiply. The default value is set to 0.5, so we immediately see our height cut in half. But if we slide this up, we can control the amount of distortion. We can make this really extreme, but let's settle on a factor of 2. Let's look at our spreadsheet to see the Z position at 1 and then back at 2 or doubled. The other node we can use instead of the multiply is a map range, so let's add that now. When we plug this in place of our multiplier, we can see that we are back to the original values. But we can alter that. The value that is coming from the noise texture into this socket is a number between 0 and 1. This is what we see in the from min and from max values. The number it is outputting is what is in the to min and to max, which is currently set to the same values as the input numbers. If we give it different numbers in the to min and to max, it will take the input values from 0 to 1 and assign those numbers evenly across whatever range we give it. So if we set the max to 2, we should see our displacement double. Watch the spreadsheet up here. The last position is our Z-axis position, so we should see these numbers double exactly. And there we have it. We can set it as high as we want to get the same displacement as we would have with the multiplier. One other neat thing we can do is adjust the minimum value as well, so that we know all of our geometry will have its Z value increased by the min value. It will then be able to increase up to the max value. Let's set the min to 1. Now the min is 1, but the max is 2. So we are back to our original displacement prior to the map range, but everything is elevated by 1. We can set the max to 3 and see that we have the same doubled values, which is an increase of 1 across the board on the Z-axis. So let's set the min back to 0 and the max to 2. If you're more comfortable with the multiplier, Use that instead of the map range and set the factor to 2. I'm going to delete my math node. Before we start adding objects to our plane, let's group our current setup for the inputs, and we'll label that frame ground. We also want to go ahead and add a join geometry node in at the end, so that we can join our trees and boulders to our ground and have all of that output. Now let's add an instance on points and bring in our ground geometry for the points. We'll add our trees collection as the instance and check the separate children and pick instance boxes. Let's connect this to our join geometry. And we see that we have one of our cone trees on every point. Our forest is a bit thick this way, and we don't have any room for our boulders or any other areas for items we might want to add later to our scene. Let's add a random value for our selection and turn down the probability. Now we have scattered trees that are not cluttered. Let's join these nodes into a frame and label it as trees. Let's add another instance on points and bring in our boulders collection the same way we did with our trees. We'll turn down the probability here too, but we can notice that our boulders are using the same random points as our trees. This is because random numbers aren't technically random. They are generated based on a seed value, so the same seed value will produce the same random numbers, and hence the same placement for our boulders. If we change the seed value for our boulders, we can see the placement change. Now, those are some gigantic boulders, so let's scale them down within the instance on points node. We can increase the probability if we'd like a few more boulders. Let's join these into a frame with Ctrl J and label it boulders using F2. Now let's jump over to our shader editor and create a few basic colors for our landscape. We'll add a brown color for the ground, and we can see that our plane immediately takes on this color in the same way that a mesh will default to the first material created for it. So we don't have to assign this color at all. Let's name our color brown for good housekeeping, and then add a green for our trees. We'll make this green a bit darker and name it green. Let's go ahead and add a gray for the rocks. And then we can head back to the Geometry Nodes editor and assign those materials. We'll use a set material set to green for our trees and a set material set to gray for our boulders. Let's frame up our final nodes and label this output. Now we can jump back to the shader editor and adjust world lighting because our brown looks pretty gray. I have a sky texture mixed with a bit of blue, and we'll adjust the strength to make it a little less bright. If we want, we can set our plane to shade smooth to make it a bit smoother. We can also adjust the factor of the mix. Now let's find a good angle for our camera. Let's go ahead and use a subdivision surface modifier on our mesh. Since the geometry itself doesn't have any subdivisions, our shade smooth did not have any effect. Now let's go ahead and render our scene. That's it for this introduction to geometry nodes in Blender. In our 3-part tutorial, we've covered everything from basic concepts and creating shapes to working with attributes and modifying geometry. We've also spent some time with points and instances and looked at an example of how useful this can be. Here are some examples of animations that I have created with Blender's geometry nodes, just to show you some of the things that are possible. Be sure to check out my Shorts playlist for more. I hope this tutorial has helped you feel confident going forward with geometry nodes on your own. If you enjoyed this video, don't forget to like and subscribe for more Blender content. And if you have any questions or want a more in-depth discussion of any geometry node related topic, let me know in the comments. I'd love to hear from you. Thanks for watching, and I wish you a very happy blendering.